Up until this point, we know that some solids dissolve in water, some do not dissolve in water. We also know that temperature influences the solubility of solids and gases in water. Now we need to know how to quantitate this solubility. In other words, how do we, if we made a solution of a solute in solvent, we need to know how to quantitate this. In other words, how are you going to label the solution? There are many ways to label the solution. There are many ways to express the concentration. Solution concentration. This is the quantitative relationship between the amount of solute and solvent in that particular solution. One of them is molarity. Molarity, we all know, is number of moles of solute divided by liters of solution. There are others: mass percent, volume percent, mole fraction, etc. And these are the concentrations that we're going to learn about in this video. Mass percent. Mass percent means mass of solute. How do you quantitate mass percent? Mass of solute divided by mass of solute plus mass of solvent. Okay, so mass percent is mass of solute, and mass of solute plus mass of solvent is mass of solution. So mass of solute divided by mass of solvent, mass of solution multiplied by 100. This will be mass percent. You can have a volume percent as well. How do you calculate volume percent? Volume percent is volume of solute divided by volume of solution multiplied by 100. But remember one caution, that the numerator and denominator in volume percent and mass percent should have the same unit. Okay, now what is mole fraction? Mole fraction is the unit, is the concentration that we use when there are more than one solutes. Now for example, consider a glass of water or a test tube of water. You can dissolve 1 spoon of sugar in it and then 1 spoon of salt. So in this case, what is the issue? There are 2 solutes and 1 solvent. You can have a mixture of gases like that too. In a huge tank, mix gas A, gas B and gas C, right? 3 gases. So what is the mole fraction of gas A? Mole fraction of gas A would be number of moles of A divided by total number of moles. In other words, if there was, just as an example, if there was 0.3 moles of A, 0.2 moles of B and 0.5 moles of C, mole fraction of A, so 0.2, 0.4 and 0.6 for example. So mole fraction of A would be 0.2 divided by 0.2 plus 0.4 plus 0.6. This would be mole fraction, and mole fraction could be computed for mole fraction. Could be computed for every component in the solution. So as a summary, ways of expressing concentration of solution: molarity, mass percent, volume percent, mole fraction are some of them. you should be able to work problems in each of these concentrations.